Observable motion in all three dimensions is the what of physics. It represents what we can observe and what we can recreate. Forces can help us to understand why these motions occur. Why an object moves at a steady velocity, why an object accelerates. But to fully understand why objects move, we need to look at the energy present at every part of that object's motion. Energy also goes on to explore how other objects move, such as waves, light particles, and electrons. Understanding energy in this sense goes beyond just the motion of objects and helps us to understand how our world and our society works and how we rely on energy to do almost every part of our lives. Let's begin by discussing what energy is. Energy is the ability to do work. Energy allows us to do things, to move things, to lift things, to transmit things. Energy allows a light bulb to light up. Energy allows your cell phone to charge in a wall outlet. Energy is what keeps an object or particle moving in a certain or defined direction or motion. Energy falls into two categories, and it flows from one category to the other. Energy always flows from potential to kinetic. Potential energy is stored energy. This is energy that's stored in chemical bonds, in objects, in atoms, and in positions. When we talk about the motion of observable objects, we're looking at how the energy is stored in the object itself and in the position of the object itself. Kinetic energy is energy in motion. We store potential energy so that we can use it in a kinetic form. We observe this kinetic energy in the motion of waves, electrons, atoms, molecules, substances, and objects. Potential energy and kinetic energy can be broken down into specific observable forms. The form of energy is based on how the energy is stored or used. One way energy is stored as potential energy is through chemical energy. This is energy stored in the molecular bonds of chemicals. Everything from food to gasoline that is a chemical that has stored energy in its bonds represents chemical energy. If you eat a banana, that energy can be transformed into motion later. Nuclear energy. This is energy stored in the nucleus of an atom and released through nuclear fusion, which is atoms coming together, or fission, atoms breaking apart. Nuclear fusion takes place in the sun's core. Nuclear fission is how we on Earth get nuclear energy. Because on Earth we get all of our energy originally from the sun, all energy on Earth begins as nuclear energy. Elastic energy is energy stored in objects that are stretched and compressed, such as springs and rubber. If you compress a spring in a spring-powered toy, you're storing energy. If you stretch out a rubber band, you create elastic stored energy or potential energy that can be released into kinetic energy. Gravitational potential energy is energy stored by lifting or storing an object off of ground level. When you lift something off of your desk, you give it gravitational energy. When you let go of it, that energy is released in kinetic energy, allowing it to move back down to the desk. We harness water in dams such as the Hoover Dam to create gravitational potential energy and then generate electricity from that gravitational energy. Potential energy is how the energy is stored. Kinetic energy is how the energy is used. This is energy in motion. Kinetic motion energy is when an object is moving. After you let go of a rubber band, it shoots through the air. It's using motion, kinetic energy. Radiant energy. This is energy in the form of light or any form of electromagnetic wave. All energy on Earth starts in the sun with nuclear potential energy. It comes to the Earth through radiant energy. We're receiving that light. This is where solar panels come into play. This radiant energy that's coming to the Earth can also be transformed into chemical energy as it helps grow food. Thermal energy is energy in the form of heat. We observe thermal energy anytime we create heat. For example, when we transform chemical energy such as natural gas, into heat by using a stove. We also observe thermal energy when we have friction. If you rub your hands together, they warm up. When you stretch that rubber band, the rubber heats up. It's giving off thermal energy. When a basketball hits the ground, not only is it compressed, but it gives off a small amount of friction and therefore a small amount of heat. Sound energy is energy in the form of sound waves. You can observe this in any time we knowingly create sound, such as a stereo, or when we accidentally or dissipate out some sound, such as bouncing a basketball. When the ball hits the ground, it compresses, creating elastic energy. It creates some friction, which creates some dissipated thermal energy, and it makes a very distinctive sound. So that sound energy is dissipated out. Or, quite commonly, we can use electrical energy. This is energy caused by the movement of electrons. At the Hoover Dam, water is stored in large reservoirs, giving it gravitational potential energy. When electricity is needed, that water is released. The water moves, spinning turbines and creating electricity. As we've observed, energy flows from one form to another. The form changes, but the total amount of energy is always constant. Consider the basketball example. When you bounce a basketball, it hits the ground, it compresses, creating elastic energy. It also gives off thermal energy from friction. It also gives off sound energy. The friction and the sound energy do not help the ball bounce back up. This helps to explain why a ball bounces only a fraction or percent of its original height. However, even though the ball is bouncing less, that energy was not lost, it was just transformed into another form. We often refer to this as dissipated energy. The big idea with the conservation of energy is that energy is never lost. It just transforms. Let's consider a hand-powered flashlight. You power this flashlight by shaking it back and forth, causing a magnet to bounce back and forth between a copper coil. This induces an electrical current. So your motion created electrical energy. So that's two forms of energy. That energy is stored in a battery, and then it creates light or radiant energy. So we've moved from motion to electrical to radiant energy. All energy on the planet Earth originates from the sun. The sun gets its power from nuclear fusion. So that means that all energy, even this small hand-powered flashlight, had its start at the sun. So I can start with nuclear energy and track my way all the way down to the radiant energy that came out of this flashlight. So the nuclear energy transferred into radiant energy. The sun sends its energy to us in the form of light. Since this is not a solar-powered flashlight, the radiant energy does not directly create the electrical energy. I created that energy by creating motion, kinetic energy. That energy came from the food I ate. That radiant energy helps to grow the food I ate. It creates chemical energy. Photosynthesis in the corn turns the radiant energy directly into edible energy, chemical energy. That chemical energy is processed in my body, giving me the ability to run, jump, or in this case, shake a flashlight. And that puts us right where we started off. Shaking the flashlight back and forth creates motion energy. That motion energy induces an electrical current, creating electrical energy. This flashlight has a battery, so it stores electrical energy. When I turn on the switch, those electrons are allowed to flow again, and it creates radiant energy. Every time that we can observe or use energy on the planet Earth, we can track it all the way back to the nuclear energy that's created and stored in the sun.